The Audio AB Machine Overview. The Audio AB Machine transforms your DAW into a high-definition capable audio gear testing device. It's like an audio engineer's workbench that's been designed for recording musicians, audio producers, and engineers. The Audio AB Machine provides the workspace and the tools to take your knowledge of audio engineering and the gear you are using to another level. It can also help you to discover issues in your signal path that are keeping you from getting the sound qualities you're going for in your recordings. For example, in the video for the null test region, you'll see the gain reduction metering of a DAW's compressor reacting to the music, visually showing that it's working. But when you listen to the resulting null sound across the 5 different musical styles, it becomes evident that the compressor's gain reduction is erratic and inconsistent. This is a clear case where trusting what your eyes see, or what you expect to hear, can lead you to believe the issue is fixed when it's not. A phenomenon called placebo hearing, first defined in the Origins of Sound Qualities course. And since a compressor is meant to add consistency to a track, not introduce more variation, such characteristics are clearly undesirable. This is just one of the many valuable insights the Audio AB Machine helps uncover or makes possible in the first place. The pink, purple, green, orange, and blue multitrack music clips are used in tests where you listen to the results. You can also import your own multitracks. The yellow audio clips are used in tests where you look at the results on real-time analyzers, oscilloscopes, and meters, which are explained in the PDF manual and demonstrated with the website's videos. The Audio AB Machine is separated into 6 regions. Each region is used for a different type of audio test. For example, after visually testing a plugin using the configurable test tones in Region 5, you could then insert that plugin on all 32 dark blue B mixer channels and compare how it affects the sound qualities of the 5 styles of music to all the light blue A mixer channels, which could have the DAW's equivalent plugin. Since all 64 channels go through their respective A and B submaster channels, colored light and dark green, any overall level differences seen by using the multi-channel test tones in Region 4 can be quickly adjusted using one fader. These multi-channel test tones can also be used for such things as showing the cumulative distortion amounts of the A versus B mixer channels, while the 64 staggered impulses can quickly reveal inadvertent channel settings discrepancies or be used to match EQ settings between the A and B gear being tested. The Audio AB Machine can also perform definitive comparisons of digital versus analog mixing boards. They're definitive because the resulting stereo AB wave files are created using controlled, repeatable methodologies and are made up of a broad representation of musical styles and instrumentation. The music clips can also be easily configured to provide complex and sparse mixes without automation. In addition, the resulting wave files include the staggered impulse responses that document the state of all 32 analog and 32 digital mixer channels for further review and verification. Speaker systems and acoustics can also be tested using the 64 tracks of AB clips in Region 2, along with the test tones in Regions 3 and 4. You should first test your 2 mics of the same make and model as described in the manual to determine if they are suitable for such tests. If so, you would then set up the routing and music clips for sparse and complex mixes, mute the B sound clips, and digitally export the music and test tones of the A channels to a stereo mix track in the DAW. Then you would mute all the A sound clips, send the mix of the B sound clips out to the speakers being tested, use the test tones in Region 3 to match mic levels, and record the B track sounds coming out of the left and right speakers onto a stereo track. It is suggested that you record the speakers being tested using a separate standalone recorder, which will prevent feedback due to operator error. If you used a separate recorder, you would load in the recordings of the speaker systems that played the B tracks and align them under the DAW's exported A track for critical A-B listening.
Hold on, hold on, hold on, hold on, hold on. You gotta be strong. Hold on, you gotta be strong.
Region 6 is used to create multi-tracked, controlled, repeatable audio comparisons of 2 different pieces of external audio gear, such as 2 microphones to each other. The process involves 3 steps. Step 1 consists of recording a number of musical instruments and vocals through the A and B gear being tested onto the 2 red-colored tracks 7 and 8. In the tutorial video, a 30-year-old very used Shure SM58 microphone is compared to a brand new SM58, with tracks 7 and 8 labeled for each microphone accordingly. The reasoning for carrying out this test is easy to understand. The thickness of a microphone's mylar diaphragm is typically around 20 microns thick. To put how thin that is into perspective, an average human hair is about 100 microns across. The diaphragm is so thin and light so that it reacts accurately to sound waves in the air. The purpose of this test is to answer questions such as, do decades of being placed inside a bass drum, or an inch away from a Marshall amp speaker, or having human beings spitting aerosol particles inches away from and onto something so light and delicate affect the resulting sound qualities? The gray guide tracks offer simple musical parts that any musician can play to create the live sound sources for the test. The 4-chord lead-in alerts the musician to get ready to play. The microphones can be moved into position for each sound source during its 4-chord lead-in. The loudest instruments are recorded first, starting with the drums, and the quieter instruments and vocals last, so only 2 gain adjustments need to be made for such a test. You don't have to play all 25 musical parts and 7 vocals, which will take about 16 minutes to record. A kick drum, snare, hi-hat, mic'd bass, piano, or guitar, and vocal is more than enough to put the gear through the test. You don't have to play the gray musical guide track parts, but know that tempi other than 90 beats per minute have not been tested. The audio clips created in this region are subsequently dragged from the Audio-AB Machine's Projects Audio folder into the empty audio folder of a blank Audio-AB Machine player for playback.
I can't see you, the sun is in my eyes.
This is an Audio-AB Machine comparison of a very old Shure SM58 microphone equipment A compared to a new Shure SM58 microphone equipment B.
Upon completion of step 1, if you recorded all the musical parts, your project window should look similar to this. You don't have to record all the instrument parts in one continuous pass. You can punch in and out during the 4-chord lead-ins. As mentioned, this video demonstrates a recreation of the DAW tutorial file, which compares an old mic, equipment A, to a new mic of the same make and model. Conducting controlled, repeatable, multi-track comparisons of the types of microphones or other gear particular to your signal path can offer valuable insights not available through casual or problematic comparison methods. If you have 2 matched mics, as explained at the end of this video and detailed in the manual, your fully mixed 64-track comparison could be of such things as 2 different types of preamps to each other. Your B signal path could also include an analog recorder. Alternatively, your controlled, repeatable multi-track comparison could involve recording systems of vastly different calibers, the results of which can be surprising. When comparing 2 such recording systems, you would transfer the analog recording to track 8 and then align the waveform of track 8 to track 7 before proceeding to step 2. Step 2, which takes about 10 minutes, The A and B audio files are normalized and renamed. Step 3. Playback using the audio A-B machine player. For playback of your comparison, copy the numbered audio files from the Audio A-B Machine audio folder into the empty audio folder of a blank Audio A-B Machine player. When you first open the Audio A-B Machine player, it looks like this. All the light blue clips were recorded with Audio Gear A. All the dark blue clips were recorded with Audio Gear B. In the bottom left corner of the project window are the spoken word audio clips. This was recorded with Audio Gear A, and this was recorded with Audio Gear B.
This is an Audio A-B machine comparison of a very old Shure SM58 microphone equipment A compared to a new Shure SM58 microphone equipment B. This is an Audio A-B machine comparison of a very old Shure SM58 microphone equipment A compared to a new Shure SM58 microphone equipment B.
On the right side of the screen is the marker control window. In Pro Tools, it's called Memory Locations. You can use the markers window to instantly play back any of the stacks of A and B audio clips.
I can't see you. I can't see you.
Because the light blue A and dark blue B audio clips are stacked and staggered vertically, they are easy to select for looping and muting. The duration and sequencing of the A and B audio clips can also be modified horizontally. In this region, starting at measure 65, the sound qualities created by signal path A can be critically listened to versus those created by signal path B, using 32 pairs of audio clips of the exact same musical performances.
I can't see you. The sun is in my eyes. The sun is in my eyes. I can't see you.
At measure 74, you can hear the cumulative noise created by the gear in signal path A. At measure 76, you can hear the cumulative noise created by the gear in signal path B. If you carried out an advanced comparison, at measure 79 is the self-noise of signal path A. At measure 80 is the self-noise of signal path B. Advanced comparisons also include the recording of test tones through both signal paths. The recorded test tones show up at measures 83 to 93 and document the state of the A and B signal path during the recording for subsequent measurement and review using the free RTAs on the yellow mixer channels 75 and 76. As described in the manual, carrying out this type of advanced comparison is required to determine if two microphones are matched enough in frequency response and noise levels to be considered a matched pair of microphones. Matched pairs of microphones are required to carry out comprehensive tests of such things as microphone preamps to each other.